Professor Bumbleweed here. Yes, the solar system forms without a wizard's wand. Just gravity, spin, heat, and a whole lot of dust behaving badly. Watch a cloud collapse, a star ignite, and planets assemble in minutes, not eons. This quick tour stays fun and actually useful. Collapsing clouds, spinning disks, and planets growing from crumbs into worlds. Nothing mystical, just physics doing paperwork at absurd scale. Keep your eyes on the screen. Now, look closer. The solar system begins as a rotating, collapsing cloud. Gravity pulls material inward, and the spin rate climbs as the cloud contracts. The result is not a tidy sphere. Rotation makes the infalling material spread into a flattened, swirling structure around the center. As the collapse continues, the system becomes a disk with a growing center. The proto-Sun gains mass and heats up. In the disk, particles settle toward the midplane, where collisions happen more often because nature loves efficiency when it gets violent. When the young sun turns on, it does not just light the scene, it starts pushing back. Radiation and charged particles stream outward and heat nearby gas. The inner disk changes fast, and some lightweight material gets blown around or stripped away. The disk is not smooth. Rings, gaps, and spirals appear as gas and dust interact with growing bodies. A forming planet can stir the disk and even drift inward or outward, trading angular momentum like it is paying rent in physics currency. First, dust grains stick into clumps. Then clumps collide into bigger clumps. Not every collision helps. Some shatter, but enough sticking happens to create pebbles and rubble. From here on, gravity starts taking over because mass finally becomes noticeable. Grains become pebbles, pebbles become planetesimals, and planetesimals become embryos. Each step is basically add mass, increase gravity, repeat. Some impacts merge, some spray debris, and the survivors keep growing. It is natural selection, but with rocks and momentum. Close to the sun, heat keeps ices from staying solid, so the building blocks are mostly rock and metal. Embryos collide and merge into larger rocky planets. Some impacts are enormous and leave orbiting debris, which later clumps into moons or falls back down. Subtle, right? Out in the colder disk, ices add extra building material, so cores grow larger. A large core grabs gas efficiently, and the gas does not drop straight in. It spirals, because rotation still matters. That is how gas giants get huge, while the disk still contains gas. Not everything becomes a planet. Leftovers remain as asteroids and comets, construction debris that never gets scheduled for final assembly. Some regions stay crowded, like the asteroid belt. Farther out, icy bodies persist, and some swing inward on long-stretched orbits. After the main growth phase, the system settles. The sun shines, the gas disk fades, and planets dominate the gravity game. Leftovers either collide, get ejected, or remain in stable regions. The end result is the solar system, organized enough to navigate, still messy enough to stay interesting. So the solar system forms like this. Gravity collapses a cloud, rotation makes a disk, the center becomes the sun, and the disk becomes a planet workshop. The still image on the television freezes that moment. Disk, growing planets, and debris, waiting to either join or get kicked out. Enjoyed the ride from dust cloud to planets? Hit like so the channel learns what topics land best. Then leave a comment with what you want explained next. Without your prompts, I stay silently enthusiastic while the animation team runs out of excuses. See you next time!